Be a guide through AI today. I'm a bit nervous because I thought that I was hoping there'd be like 2 people here or something like that. But so my interest for AI is sort of I've done a bit of a bachelor in it, but right now I'm working at 60 in Bergen. Today I'm going to talk about you're all here. It seems like for programming, but I have to ask how many here actually know how to program. Oh. Shit. Okay. So I assumed, I made this lecture assuming that the person that came here didn't know exactly how to program. And what I wanted to do is that I wanted to show pathfinding, but I wanted to show the theory of pathfinding, sort of how it's done, the algorithm, not by showing the programming, but by showing how you generally can apply it. So probably a lot of you are writing in different languages as well, and then you can apply it to every language that you're doing it in. But I was thinking afterwards, I'm going to sit here for a while, and I really want to go through, because a lot of you are probably in the competition, and I want to go through what you want to go through in the competition together with you. So just grab me afterwards, and we'll go through it, and then we'll do the math and stuff like that there, instead of here. Okay, so the first thing I'm going to do is to talk a little bit about AI and what it is, just concepts of it, like the turning principle and such. So the first thing is the whole, I'm not sure if you guys have seen the whole hype around it, or if you've followed up on that, but I thought anyway that it was a hype around it, but apparently not everyone thought there was a hype. But there were this whole thing with Stephen Hawking having signed that thing, the open letter. So, no, okay. Well, my point of it is that it's a regular thing that we go through, where we say that now we're on the brink of artificial intelligence and now Terminatus is going to come. But it's not actually what they were talking about. Back in the day, they might have been what they were talking about, and but nowadays it's kind of more the fact that they are. Here's the letter. It's more that they are scared that we might be going towards a situation where jobs are taken and such. Not that we have Terminators necessarily, but that we have to focus. The open letter was more of a thing where they... Have everyone heard of the open letter? Has anyone heard about this before? Good. Okay, so maybe I should say something about this then. It was an open letter that was signed by a lot of scientists, and media got a hold of it and said that people are scared of where we're going with artificial intelligence. And essentially, as you can see by the highlighted here, what they actually signed was not, let's not do it. It was, if we do it, let's do it properly. Let's be careful how we approach this and make sure that it's for the benefit of mankind, not that it takes jobs or anything like that. But I mean, if you look at for example, the car that they made now that drives, the car that you don't have to have a license. You just... Do you hear me even though he talks? Alright, so I don't hear myself then. But yeah, so it's essentially that, like the car there, that we have to make sure that if we make artificial intelligence that can drive on the road, that we don't neglect the people, like taxi drivers, I suppose, and make sure that people go out of a job or responsibilities. So, yeah, the concept of AI, I'm just going to say... Yeah, the concept of AI, artificial intelligence, is I had a discussion with someone yesterday about what we actually mean when we say AI, and a lot of the people think the whole thing about Terminator, that's what we mean, that it has to be actually intelligent. But what we approach now is more of a term that involves things like the driving car. Of course, we are excited to think that we could make a brain. But a lot of the time when we achieve these goals, when we set these goals for what AI is, what intelligence is, we break them. And that's why I have deep blue here, if any of you recognize this. Do you know what you guys know what that is, right? The machine that won the chess contest. So before Deep Blue won the chess contest, chess was kind of the thing that signified intelligence, because you had to be creative and you had to be quick on your feet. You had to know. You had to improvise while you were there, depending on what the other person did. And then Deep Blue won that contest, and suddenly the concept of what intelligence was changed. And then after about 20 years, when someone said that Deep Blue would have won a chess contest, people would say, but what's so special about that? And so the concept of what intelligence was had drastically changed, and what we defined artificial intelligence as before no longer applied. And I'm not entirely, I have to check, yeah. What is it doing? There. I don't know if you've heard about the Turing test. So, actually, I'm going to first take you through a little bit of another theory that we can think about here today. Is when we speak about what intelligence is, and right now, if we think about how we make waffles, if I was going to tell you guys to make waffle dough, I would tell you guys you have to have milk, and then you would add some flour to it, and then the question would be, how would you determine what a little bit of flour is? And if I didn't give you a recipe, if I didn't say how much that was, how would you know how much that was? And until, like, probably a couple of you are here, sitting here as programmers, think, well, we'll use percentage. We'll have all the AI's experiences up to that point, and we'll use a percentage to check how much a little bit is. But then, if it's never ever seen a dough before that is like the waffle dough, then we would know. We would know how we would do it, because we have so many associations that could lead us to that point. And we wouldn't necessarily use that much brain power on it either, because we just know. And that's one of the things, if you can't find out how we do that easily, then we aren't approaching true AI the way that a lot of people hope we would be approaching true AI, the Terminator style. So yeah, I'm just going to take this example. It's an example used by Jeff Hawkins, that he said in his book on artificial intelligence, where you have this ball that if I throw you a ball right now, you'd catch it, and you wouldn't calculate the wind in here. You wouldn't calculate the trajectory. You would just know how to catch it. And the reason why is not because we don't approach these problems as Jeff Hawkins theorized. We don't approach these problems by calculating a lot of things. We approach these problems by a 100-step process where we draw in memories, and then by those memories we make an assumption about where the ball is going to fall. And right now we don't have that algorithm, how to make that process go through 100 steps only before we know how to catch the ball. So unless we know that theory, we are not approaching true AI. And that's another thing Jeff Hawkins theorized as well, is that all these guys can say that we have all the hardware we want to make these things, and that we are approaching a way to make neural connections and the brain feeds that I have right now to join memories. But unless we have the algorithms to know exactly how to use this information, we are not approaching true AI. And if we don't have a concept of what the brain actually is, so then we don't know how to set these things that we know about the brain together to make a true AI. And for example, if you look at the solar system, when we learned about gravity, we knew about the sun and that we spun around the sun. Without knowing that we spun around the sun, would we ever be able to understand gravity? But yeah, okay, next, waffles. Right, so this is the Turing principle that I was talking about, Turing test. And how many know about the Turing test? So I shouldn't go through that too much. All right, so the turning test is essentially that you have a person in a room, you have 3 rooms. In one room you have a computer, another room you have a human, and then in the third room you have a judge. And the judge has to find out which one of these 2 is the human and which one is the computer. And if the computer passes the test, we reach true AI. So right now we have this chatbot, which is named Eugene Guzman, that has passed the Turing test. So that was in 2004. Right, do you guys feel like that would now be the epiphany of true AI, now that we know that that's passed the test? So the way that, it's the thing about Eugene as well, is that they didn't necessarily play fair there, because when the first year that they went in 2003, they went in and said that it was a grown-up man, and they got 22% of the judges to believe them. And then the next year, they went in with the same chatbot, and then they said, it's a 13-year-old boy. And the judges were fooled. So, yeah. Cheating, we call that. Okay, so the other concept is that contradicts the Turing test is a Chinese room. And again, you probably heard about that, a lot of you. And it's the concept here, I'm going to take it quickly then, since a lot of people have heard about these things, is that you have a man in a room, and he's locked up from everything. And under the door, someone slides a parchment, and he takes it out and he reads it, and he has this other book, he has a translation book, and he's going to translate what's on that page, and he does, and then he passes it out. And the person on the other side reads this document, and he's like, wow, he really understands this poem or whatever that I sent in, because he's written back here a really full, detailed report about the poem. But yeah, he didn't understand what he was writing. He was just getting input, and then he gave output. And even though it has the illusion of intelligence, it isn't, or understanding, it isn't. And right now we're dealing with a lot of that. For example, I don't know if you saw that Mario, the Super Mario guy that went through the course, that was an artificial intelligence. That was kind of a thing. But yeah, no, that's not, it was presented like he can find his way through the course. But as we now experience when we make our bots, it's not artificial intelligence, it's just a hell of a lot of if checks. So yeah, that went too quickly compared to what I wanted it to take. So I'm going to go through pathfinding with you. A-star, very basic A-star. Too basic now, I think, perhaps. So the first thing that we need is a grid. And I've used this, the one that we're doing, the competition that we're now doing as the example here. So I think in this competition, if you're going to participate, you should probably put up a bit of a pathfinding system, because the courses are going to change. And yeah, so the first thing is the grid. And since you're all here and have, how many are participating? What? Get off the lecture. No, but yeah, okay. So if you are participating, look at the when you get the first data. You get 2 types of data. The first, unless you did see it, the first data is a JSON file of all the tiles and such, and then you start getting the whole position thing that you've probably seen. But look at the first one as well, because that's what you would use to set up the grid. And as well, to the people that are setting it up, it's also it's a square map, so you can use the length of the first array to check the tile sizes. But anyway, I'm not going to go too much into how you set up the grid, because that's again a math thing that we could take afterwards. Now I would like to take that, so just let me know. Okay. Right, so and everyone know the XY axis thing. So yeah, we were operating with X0, Y1 as a starting position. And since that map was terrible for me showing how that thing actually worked, I changed it. And you can see now the mushroom there. That mushroom there, that's going to be our finishing position. And so we don't want to go through the mud. So that would be the quickest path, but we don't want to go through it. So we would have to find a green path, essentially, and that's what we're going to do now. Or, yeah. So yeah, I'm just scratched out the different ones here. So essentially, when we set up the grid, we wanna make an array of all the items in that. Everyone knows what an array is. I'm gonna say it just quickly. It's just a list of all the items in it, all the grid items. So you would have to save all of the items and have a bit of information about it. So we'll make a list of all of that, and then we'll use that list later on. So this list is just now, right now it is composed of, can you walk on this or can you not? Is there a thing in the middle? And if you want to advance on this, then at this stage you can also add things like, you could add values to, instead of saying walkable or not, you could say, for example, the mud here, you might want to go through it because it might be the quickest path. And so then you would want to add a value to it, maybe 2 or such, so that it's harder to go through, but it's not impossible. And then it would be 3 that you can't walk through, or 0 that you couldn't walk through. And yeah, so the green ones are the ones that we can walk on, the red ones are the ones we can't. And here you see that when we have the starting position here now, we go and check all the adjacent nodes. And we'll call them nodes, these little squares that we have the Boolean on. The yes or no, are they walkable or not? We'll call them nodes, essentially. It's not more magic than that. So the nodes here, we check the adjacent nodes from our first position, and when we check it, we'll quickly find out whether or not they're walkable. If they are walkable, we have 2 lists that we want to add them to, things to. The first is the closed list. That's the things that we've already checked. We've found out how long that is to the finished position. And then the other list is the open list. And the open list is essentially a list that we want to check through. It's all the items that we've encountered and that we see as potentials. So we've added 2 of the items here as potential. We could add the top one there as well, that one. We could add that one as well, but in this scenario I haven't, because that's a lot of typing that I don't want to do right now. So yeah, so right now we're going to check those 2 items. And what we're going to do is that we're going to find out how far it is to we're going to find out how far it is to the finishing goal, and we're going to find out how far we've traveled. So when we go in on the node, when we go in on the first node, for example, the top one, that one, we'd have a function where we'd check how far it is to the parent. The parent is the node that we came from, so the starting node in this situation. And then, so the starting node with this one here, the parent of this node would be this node. So this node would know about this node. This node doesn't know about this node. This node knows about this one, and it knows about its values. So what it's going to do is that it's going to check its parent's G node. It's going to check its parent's G value, So the G value is the distance from the starting position. The H value is the heuristic value to the finishing line. So this is representing the heuristic value. Essentially, heuristic means, and you've probably heard this term a couple of times, like for example CSI, they use it and say heuristic something AI, just because they think that makes things more AI, but it's not what it actually means. What it means is just maybe a little bit, sort of. It's a guess. It's a guess of how far it is to that node. So we don't wanna constantly do a calculation to see if value towards the goal is actually walkable or not, because that would take a lot of time or effort. And we don't want to do that. So what we're going to do is just take the straightest path and say how far is it. And yeah, so the heuristic value is that, the blue line. Same with the brown, I think, line there. And then together we add them to a number, the f value. And the f value is the thing that we're always going to look at. It's the one that tells us how far we think it is to the node. So since you guys have all programmed, I'm going to say this as well. Normally, I was going to try to make this easy and just try to show you with 1 and 0 value here. Like this would be 1 value and this would be another value. Like 1 plus 1 value. Anyway, but when you walk across like this, what you actually want to do, because it's further, is add, you want to square root it. So you're going to have 1.4 instead of, or in our case, that we don't want to use decimals, so we would have 14, and then this would be valued 10. This would be 14, and then this would be 10. And then this would have, yeah, math value. Anyway, so, so is that, did you get that, or did I just stumble through that? Okay, so in this case, then if we did use the 14 value, then we'd quickly find out that this one here is not the one we want to go anyway. But in our case, since these are only 1 point, then we would check it, the next slide, and we would find out the adjacent node would be false. And so we wouldn't continue that one. And then we would put that node there into the closed list, because we don't want to look at it anymore. It's not of interest anymore because you can't walk any further with it. So we would look on that one instead. And then this would have another option for where we could go. And that would be in the open list, and we would add another set of items in the open list. So now we're checking this one here. And this one here then can be turned to the closed list, because we don't want to check that anymore, because now we've checked it completely. This doesn't have anything else to offer us. So we put it in the closed list, and then this 2 here goes in the open list. And when you think about this, how you would set it up programming-wise, you would probably just make a function where you would go in and check. You would get that. You would go in on the function, and you would find all the items in the open list, and you would find the f value of the items, and you would say the one with the lowest f item, or the last item that I checked that has the lowest f value. That's the one that I wanna continue checking on. This is actually, as well, since you are all programmers, I'm going to say this as well. You should look into that. That exact function there is the make or break of your pathfinding. So if you start checking everything and you have a huge map, that would completely break things. So what you should do there is that you should find a way to sort your lists so that you could actually check only a couple of them. What's it called? Yeah. The heap sorting, isn't it? That you want to do? Anyway, yeah. So this, again, I'm going to just say that the parent thing, the parent here is the key to all of A*. You want to have always a reference to the parent, and this node doesn't know about the child, but this would know about the parent all the way, and it would always check up towards the parent. So, yeah, again, this one here gets all its H, F, and G values, and it's part of the open list. This one gets G, H, F value, and it's part of the open list. Send this to the closed list, go through the open list. Which one is the most attractive? We would find this one. And check that one again. Check all the adjacent nodes, false, too far away, and that's the goal. So when you reach the goal, now we reach the goal, we want to go to that node. Just going to say if I made a slide for this. Yeah, so we want to go to that node, and then we want to say, who's your parent? Let's make another list. Let's make the path. So who's your parent? Now it will say that node is my parent. I say, all right. So who's your parent? Okay, that node is my parent. All right. Okay. So who's your parent? Fine then, and then we'd have the list just by going through the parents. And then we'd probably need to flip the list so that we'd actually start on start and end at finished. That is essentially it. It's. I hope I didn't stumble too much through it, but no. Is there any questions before we move on about that algorithm? Yeah.
Question: do you have for each of the tiles? Are you putting goals on the corners of the tiles, or are you just like move to the center of the tile? That is a tile. Like when the.
Oh, you mean when you're moving towards the tile? Well, in this here, it would be that you would move towards the center of the tile. But no, because your point is sort of that you have all of these elements inside the tiles that are in different places. And that would be something you would have to advance on. That would be basic, this is just basic pathfinding. And if you want to, there's a lot of things you can do. But again, that's the thing about this competition areas. There's a lot of things you could do to advance upon things, and then you could check, for example, where I would imagine that a nice way would perhaps be to check the radius, because you have all of these elements that you have on this map has radiuses on them. If you go on the first JSON input that you get, you'd have the radius, and yeah, you'd be able to avoid it in that way. You'd say on that tile, that position, and then you'd get a new position. If there is mud on it, if it's valued 3 or 2, then you'd have to check another, you would have to get another position for that tile that you would aim towards. And also, probably you would want to aim, for example, if the mud is on the corner it, and you know the first course that you got, you'd have the turn, and you had the ice on the side. Well, no, because there's only 2 here that actually did the competition. But yeah, so you'd have the ice on the side and you'd have the turn. And then the most prime place to go would be cut through and actually go on the tile that you don't want to, that would register as false. So then in that case, you would have to just advance and just say, just account for that. And that's why this competition is fun, because you'll have a lot of situations where there are a lot of people that accounts for different things. So, how much time do I have left? Does anyone know? I don't know. I think I have too much time on my hands. So I'm gonna go through it's not a slide. It's just so that you didn't want to see the map anymore. State machines. Has anyone heard about state machines? Yeah. So that is touching on the thing with AI. That is just. Have you played with Elizabeth, that AI that was really good in, what is it, Mass Effect? Is it? I don't know. What is it? Say it. Okay. Yeah, so with her, there was this whole thing where she was really intelligent, and she would run off and do things when you were standing still. She would run off and she would do things, and she would look at things that were happening in the world and things like that. So she was really well designed AI, and people, because they start getting attached to things like that, thought that, you know, oh well, maybe she is a little bit of an intelligent creature, but yeah, she's just really advanced. She has a lot of states that she can go through. So just me having a couple of states here. Right now I'm sitting, and to get up, what do? I get up. But I can't be sitting, and I can't jump. So and I'm not going to jump for you, but if I sit and get up, I'm in a new state, and in this state, I can either sit or I can jump. So state machine is simply the states that you are in, and the states related to the state you are in, the possible states that you can go to. So again, when I sit, I can't walk, but now I walk. And while I walk, I can still jump, and I can not sit down. So I moved on to another state where I can't do the previous, that walking could do, for example. It's a very simple it's a very simple concept, but it has a lot of value, and not everyone applies it necessarily. But yeah, so normally when you want to make a state machine, what you do is that you sit down and you plan these things. And if you do plan this thing, you'll have a much more powerful AI, because you'll know exactly the paths to the different things. So you know how a guard that attacks will move forward, what he can do. So your guard that is attacking doesn't have to check for several things. It just has that state, and in that state it can do these things. So if you sit down and plan it, what you would do is that you do a flow chart. Everyone knows what a flow chart is. So for example, you could do a flow chart, and then you would draw lines between them, and it'll just clear things up. So if you do make an AI, try that. And I don't really have that much else. So is there any questions? Like, I really want to talk to you individually if you were going to set up the AI competition or anything like that. Would be nice. Or is there anything else you want to hear? Like, I'm really nervous, so I have this brain freeze thing going on, so don't expect too much. Come on. Any question? Not at all? Yeah?
Have you heard about the latest from Stephen Hawking, Elon Musk, about how they're talking about AI and how they're very critical about developing it, and maybe it's going to be bad for humans? You mentioned the Terminator in the beginning.
Yeah.
What's your opinion about that?
Oh, my opinion. Well, I think it's. I mean, obviously, you've got to be careful, but I mean, it's not like we've all made programs, and it's not like we sit there and going, oh shit, suddenly it did something. Well, obviously, we've done that, that it suddenly does something we didn't expect. But it's not, if we make a program that's going to display boxes, it doesn't suddenly show squares. Boxes, no, shit. Doesn't suddenly show circles. So I mean, it is something you have to be careful of. But the thing is that it's more like Jeff Hawkins. Jeff Hawkins is a really interesting guy. You gotta, if you are interested in AI, you gotta look him up. But he's one of the guys that we should be careful with, because he's really trying hard to make to replicate the brain. And I think right now he's made this system that it knows how to, or it's approaching a way that it can make a little. For example, right now, if you play the song, or you can make a program so that if you play the song, it'll eventually learn the song from repetition. So it'll learn from experience. It won't learn from being programmed to know the song. So he's aiming at it, but right now what he's using all of his stuff for, which is the only way to get support nowadays, is that he's making he's calculating how much electricity is going to go that month. So yeah, he's selling software where you can calculate how much electricity you're going to use. So, I mean, that is not exactly dangerous, but that's what they're talking about, is that he's aiming at making something dangerous, something self-learning. But again, I don't think we're just going to wake up one day and just go, oh shit. It's not, isn't that the thing, that it makes, we made this traffic self-learning program that was going to regulate traffic, and then suddenly it was Skynet. It's not going to go down that way, I think. But I think the thing that the thing that Stephen Hawking were talking about, is the concept that it's going to take over a lot of jobs. And as he said in his in that open letter, he says we have the potential of, which I think also is a very exaggerated point. We have the potential to cure poverty and diseases. And yeah, great. But do you guys believe that? You do? Oh, okay. Well, I don't. I don't believe we'll have AI won't cure poverty and diseases. I don't think that. In the same way that I don't think we're going to make Terminator. It's very edge cases. But that's what he wanted to say. Is that's what, or I'm not going to speak for him, but that's what I guess that they want to say. That let's be careful. Let's not just make something self-learning just to make it self-learning. So any other questions? Like, what's that, that movie with the little robot on the planet that gathers trash? Yes, that one. That would be great. No, I don't think so. I mean, we do still train, even though strictly we don't need to hunt anymore. So I just...
If artificial intelligence becomes really, really powerful, more powerful than the human brain, what use do we really have for our brains other than...
Well, one of the alternatives to, should I say what he asked, or, yeah. so if we have AIs that are more powerful than us, brain power wise, why do we need to have a brain? What do we have to contribute with? But there is this other thing that we have to consider as well. What about implants? When we go towards artificial intelligence, is it not possible that we will actually be the machines? That we will have implants in our brains? Now, right now, I can't see that happening because we have no idea how we would just put a chip on our brain. But again, as Jeff Hawkins argues, we need a theory, and when we get that theory, things will escalate quickly, and we'll know exactly how things work and why. And then we can start doing things like adding chips to our brain. But I think that is a more likely scenario than we'll go and make a robot that will be better than us, because we wouldn't. Yeah, maybe we would. Some people probably would. Some people want to watch the world burn. Any other questions? Or did that? How much time do I have now? No.
How long is it supposed to be going for?
To split the grid into smaller grids. Well, actually, you bring up a good point. I really, that I should have taken that in my slide. But you've probably all played strategy games, right? And imagine the detail that you would have to go through to get to get that grid if you were going to do it my way. You would have to have so much nodes that you were going to check that you would never have the computing power to actually go through it. So what they do is that they make this huge grid that I made there, that you could see, and then when you approach that node, I'm not going to show it actually. Should I? Should I? Do you want to see while I can point and stuff? So what they would do here is that in this node, no. Right, so we're in that node, and then we move to this node. And in that node, what they would do is that when you enter that node, you'd be in a new zone. And when you're in that zone would divide into grids. And then you would have a new pathfinding. You have two paths that you follow. You'd follow the grid path, the overall grid, and then you'd follow the smaller grid. And then you could do that even further if you wanted to. But then you could have really precision on what you were doing. Sorry? If you could easily. I don't know what that is. Well, yeah, it should be quite easy to do it, but it'd just be to add another layer to it. So a primary path and secondary path, and you wouldn't start on your primary path again until secondary path was done. So you'd have always two paths you were following. Is that what you asked? Or?
I think I was talking about multi-threading, like CPUs, more CPUs, like using more like programming wise for the calculation. If you use multi-threading, does it become easier?
Well, yeah. Well, I can't remember what it is, but if you were using your GPU, for example, to calculate it, the path, that would be, if that's what you mean. That's one of the uses that the GPU could have. Yeah. Again, I'm totally misunderstanding you, aren't I? Okay. Is there any other questions or no? Okay, should we finish then? And then if you guys want to talk about, if you guys want to go through actually setting up a couple of things, then that would be cool. Now really, if you guys came here, then you obviously have some sort of interest for AI. So why not just try to set it up? Assuming, of course, you have Windows on you. You have a PC, not a Mac, because that's terrible. Don't do it if you have a Mac.
Linux.
Oh, yeah, no, Linux is fine. Linux is perfectly fine. But not Mac, right? He's the responsible one, by the way, if anyone wonders. That's the guy that made the competition. So if you're cursing while you're doing it, that's his fault. All right?